continue on the agenda now with a contribution from Oksana. Oksana will tell us a bit more about coffea-casa, which you've seen in use already in multiple contributions yesterday, and also how we can use coffea-casa to run analyses at scale. Oksana, I can see your screen already. Please go ahead.
Hey, yeah, I have a very uncomfortable setup, so I will just like turn off video. So I would like to start with the slides, and here I will just go very quickly, but I would like to explain some concepts that we have in coffea-casa. Okay, here it is. So what is make it different coffea-casa from other, let's say, analysis facilities that you're using, or for example, Swan, or even Notebook, maybe in your university, that we are trying to adapt as much as possible new things that are preparing other groups and software developers in high energy community for high-lumi LHC. So what we would like to have is a modern authentication, tokens, macaroons. We would like to have efficient data delivery and data management technologies. That's why we widely try to adapt, things as soon as they're available, or even help to test, like in case of Skyhook, for example. And we base, so our main concept is we want to focus on columnar analysis, and of course to support new Pythonic ecosystem, but we also kind of open to other things, but mostly it is focused on what we showed now until now. Also, the other part is that we would like to have it a bit more like dynamic deployment. So basically, you can we would like to use modern integration techniques, which is allowing you quickly and easily redeploy or add new part to create something looking like a building a Lego block, building Lego blocks. Support of object storage, of course, efficient data caching solutions, and the easy integration with existing HPC resources. We focus, currently we're building everything around coffee, so it's our main framework. And what is, I mean, if we talk about our building blocks we're discussing yesterday, we're basically trying to accommodate everything that you saw as a proposed tutorials on the software side. So it's open for everybody. Like you saw, open data facility is used. You can just come there. We don't have a lot of resources, but it is just ongoing process, and we got the new hardware. Yeah. So wait, opposite side. Our main building block that we rely a lot is Dask. So it's a nice task management computation framework. It really allows to expose low-level APIs, so you can build very like custom system, for example, your in-house applications. It integrates with HPC cluster, so running on variety schedulers like Slurm, IRIS-HEP, Condor via Dask job queue module. So, and this allows us basically to create some kind of user level interactive system, but in the same time, you are queuing to batch system. You can run inside your Jupyter node, but actually you as well can, you can download your secrets from your session and use it directly from your laptop. We're testing this now. So how looks like your current experience, for example, I don't know, in your university, or maybe in LX Plus or something? You usually have interactive user access node, and then you have queue, and you submit jobs, and you have remote data access. And basically nothing really personal that you have, maybe except of your work directory. Everything is shared between users. In this case here, we try to add to classical system. We wanted to add Kubernetes resources as a possibility to quickly deploy and develop a new generation of software and services. For this reason, you have Jupyter Hub, which is shared between users, and then each of the user getting this nice pod, basically what you saw when you log into coffea-casa. You got your Dask scheduler, one Dask worker actually always available for you, so you can start quicker your computations. We also deploy their service seeks, we deploy Xcache, sorry. And we also deploy working now on Skyhook to give possibility to test it. And basically here you see that there is nice pipeline, which is allowing us actually transparently as a users to get access to all these wonderful services. In the same time, what it offers to you, that in the moment when your resources like not enough for your analysis, for example, you easily can scale to the shared batch queue. For example, in our case, is actually tier 2 site at CMS. Here's a lot of details about what we actually use here. Important part is that you probably notice we don't have X509 credentials, particularly because, okay, for open data, you don't really need most of the data actually is public. But in case we have CMS instance and there is available Atlas instance, we're trying to use mostly tokens. We're trying to use so tokens for everything, for data access, for the job submissions, so you don't need to worry anymore. You just go and write your code there. And we have we develop a highly customized Docker container, so you can just probably even reuse if you're interested to have it working in your institution. And also we wrap everything, so we pack everything in the Helm charts. We do some development on the top of Dask job queue because we want to make as much as possible comfortable user experience. So we hide all the settings or all interesting pieces that you probably don't need to know as a users. We're hiding them behind coffea-casa cluster, and we are looking into new backends. This is magic how it happening actually, how we able to work with tokens, but in the same time there is also, for example, XRD is enabling possibility now to work with the token, so it will be our next step to test it. It's required actually a lot of, so we have these core libraries and we are trying to integrate multiple different services via plugins to the to coffea-casa. Also, we are trying to be not only like a standalone instance, but we are trying to see how we can integrate in full distributed ecosystem that is planned for high-level LHC, particularly data lakes, and of course looking into how we can improve data delivery service experience. So now I'm not like who has access to open data. In case you probably can just log in and check out, I just want to show you how actually looks like scale out itself, how we can submit jobs to HT Condor. So in case if you will log in, you will see here a new repository cloned for you, and there is directory examples which are run on open data. Analysis instead is actually on CMS, but I will show you still. Okay, let's switch to the next one. So this is on open data coffea-casa, and we will go to check out example. First thing, when you log in, you need to take a look on this nice blue box, which is showing you actually your already made for you small Dask cluster. So it has scheduler, and it has actually usually 1 or 2 workers. One worker is a sidecar, and which is just the Kubernetes worker. And the other one is already something starting in my case, I was just running before. So I still have, I don't know why, 1 worker, fine. So we will try to run a very simple, small example. It is a part of ADL benchmarks, which is language specific benchmarks, but they show a very nice small mini exercises how you can basically learn how to use coffee nicely and all other concepts. So let's try then. Let's see what is happening.
These notebooks are available on coffea-casa?
Yes. So if you log in to coffea-casa, sorry, actually here, I made a mistake. If you log in here, I wanted just to show you so you can play later, so you can follow later. But each of you, when you will log in to coffea-casa, you will get here one of the directories called coffea-casa tutorials.
We don't have this coffea-casa tutorial. We have coffee only and analysis grand challenge, not the coffea-casa tutorials.
Can you restart your server, please? Just do like this. Hub control panel, stop, and then start. I will not do this because I want to show, but look, it's more about watching. So I would like you to see how scaling is working. And then after, you can build your analysis. Basically, the most functional code here, the most interesting code here is Dask executor and how you write a runner. So you mentioned Dask executor, you already have a client. So let me just explain. And if you want, you can write inside the Zoom chat. There is Carl who can help you to how to restart server. You do file, hub control, stop server, and start server. When you will restart, you will have there this repository available. Okay, so we are back to the example. So I will try to run this example. Am I already running something? Yeah, okay. Now I have 2 workers. So as you see, currently in this moment, I have 2 workers, and I'm starting my basically pre-processing step, probably. As you see, in the list of workers, I have currently 2 workers. And okay, now we start to scale. As you see, we're going to have now 14 Condor workers. And in this moment, now we're starting the job there. Let's try to 1%. It should be pretty quick, in fact. It's probably a bit too much workers for such a small example, but then I will show you a realistic analysis written by one of my colleagues from University of Nebraska, where we could try to, I wanted to show you a magic, actually, what Dask lab extension and particularly Dask monitoring can offer you to be able to do performance monitoring of your code and do some nice investigations, etc. All right. We could see the load, for example, other interesting things that we could see is how much workers are busy. For example, you see memory, limit, CPU load, and etc. There is also magic link here where you could click, and actually you can open like a bit better visualization of monitoring, where you have tons of interesting details about. And you can, for example, see the Dask computational graph that it is built for you in this case. So where you have a red one is like if data is in the RAM, green one is like, I think it's like running, like processing, right? And then it's basically like it's built over this typical MapReduce schema that Coffee is deploying. The other interesting part here, you could see your tasks, which are between all your workers and how many tasks has each worker. Let's see what is happening. We still have workers, and let's see how is going our example. Today is a bit slow. And let's try to understand what else we can find out why this. So the most interesting part here is a task stream, where you could actually see how all your tasks are distributed over time. And basically, if you imagine, this is like tiny lines, it's each of the threads or cores in this case. We could see that yellow one, it was a signal, I think it's from the previous one. Okay, this is our interesting part currently. So
this is from example 8.
Yes.
Notebook, right?
Yes, yes. So, but you can run any of examples. We're just, I'm not physicist, so I'm not talking about any physics, let's say. I just want to show you all instruments that you can work later. So you could just write your analysis super efficiently and try to understand how you can tune performance in this case. Yeah, so let's see how it's going. It's finished actually. No, wait. Yeah, I was here. Yeah, so it's finished. I will try now to run something a bit bigger, but you will not be able to run it because it's required to be on CMS coffea-casa. But in this case, it will allow us to do some mini investigation because it's a bit longer run. Okay, so let's see. We had for this small example 26 workers, which is kind of a lot considering that this example is not doing a lot of interesting work. But yeah, it's kind of nice that you can get some resources just like this for free. And try to scale. So here we use actually Xcache. We access all data through Xcache. That's why it should be slightly faster. Okay, we started our processing. Let's go back to our monitoring and let's try to find something interesting. Just a second. No. Okay. This example still didn't finish. I will just stop it. Just want to run this one. So now we will start to scale back. We will see here more workers. And I hope here we will get a new, so you will restart your dashboard URLs in case. But showing still a previous one. Okay. it still shows this one. So please start to look from here. Basically, this we started our new analysis, and I don't know how to clean it. I will just try to scroll the most interesting part. So what we can see, we have here all our different tasks. So we have lambda, reduce, and we have our processor, which should be signal processor in this case. Okay, here it is, signal processor. The blue one, please, it is from the previous example. So in this moment, we could see that if we check out what is happening on the level of, we still doesn't start actually any useful computations. So it's still 0%. So we could check out here that what is happening. Is it still waiting? Oh, let me start again. Okay, finally it's clean. Okay, 1%. Let's start again. I'm very sorry. It's usually when you do some live demos, and it is pretty pretty strange when nothing is working. Okay, fine. So I will show you other things that could be useful for you. It's about profiling. Profiling is your possibility actually to see, so it's kind of integrated profiling inside Dask. They wrote their own version, which is allowing you to see all possible basically call stacks from the from all your workers, and in such a way you could watch activity over time, what is happening. For example, you are interested in this moment, and you could see how to read this flame graph. This you start with the lowest line, which is showing you the function that was called, and then each of the function that is called within this function. So for example, here we see that we are doing some automatic retries of reading data, looks like, and as you see here, we're going already uproot. So since coffee is calling uproot, we are trying to read members and etc. So it's pretty useful if you would like to know, for example, what is happening in your I don't know, code, and you would like to have insight about. The other interesting thing that you could take a look is you can go to info, and here you can have a list of the workers. As you see, some workers, you see their member use, you see occupancy, you see everything. And then from this moment, you could see actually what is in memory tasks for this worker and what are processing tasks. You could see it's more about, of course, it's transition log, more useful for the, if you know well, the Dask, how works Dask. But for example, what could be nice, you could see the call stack, and you could kind of try to, you know, understand where is your performance bottlenecks. So I think it's pretty cool feature in case. Then, of course, you could try to understand the performance of your scheduler and try to see how much in average memory we use and CPU, and if something is going bad with your code, you could try to follow up here. And let's mass. So about, maybe I wanted to slightly quickly explain about these colorful numbers, colorful. So for example, you could see that here is like blue. Okay, it's your specific task. But in case if you see red or orange, that after you can just investigate. Red is usually means that this is a gathering dependency. So you can try to understand if your code has some issue between like building your dependency graph, a computational graph. And if you have a lot of red, it usually means not very good sign for the for your code. So you could probably try to optimize it. And there is a lot of different techniques. Gray means serialization, which we see that I have some issues here with this example. And white is actually pretty bad because usually your you don't need to have, it's very bad if you have so much white, let's say, space between all these tasks. It means that or Dask is not working properly, or maybe your code is not working properly. So something is with the scheduling, and you could try to take a look and try to understand why you have, for example, between this yellow task and this one red and then green, and then so it's more about, it will help a lot for you to understand actually how to make your code faster. Yeah, so this analysis is, I think, is working like with 90 gigabytes of data. So that's why it's slightly long, but I just evaluated this morning and it took me 12 minutes. So this is, yeah. This is everything I wanted to show you. Sorry for this slightly chaotic presentation. Maybe next time we will try to allocate larger slots so we could do scale out and coffee training together, so you could just learn better how to write executors and how to work with Dask and HT Condor. Here, I just wanted to show you more about that. Using coffea-casa, you could pretty focus on writing your code and then try to use all these small interesting features that we try to offer you. We're still on the level of prototype, so it means that we're open for suggestions. We're open for anything. Yeah, thank you so much.
Thanks a lot, Oksana. It was great to see a bit more about coffea-casa, and also seeing here how things scale out and how many resources are actually available to check on the performance of everything that's happening. We have 2 questions on Slido. So I don't know whether you have Slido open, but otherwise I can also read them to you. The first one from that is, are user bearer tokens used in your setup?
Sorry, can you repeat again? I think I didn't hear it.
Are user bearer tokens used in your setup?
If I'm using
let me ask it again. So the tokens that you send around, how many are from the actual end user, such that activities done with their token?
So we currently, for coffea-casa, we use we are mapping everybody to one user for CMS Java. So basically each user has a different pod, it has different but at the end, from the point of view of we generate tokens for one identity for CMS Joan. We're going to allow more to move to multiple identities. I don't know how to say, to support of, but currently this was the easiest way to deploy. I don't know if I replied your question.
Yeah, you absolutely did. Thanks. And first of all, thanks for a nice talk. I mean, yeah, you suffered the live demo problem, but it was really, really nice.
It's always like this. So yeah, I just checked 1 hour ago and everything was smooth, but live demos are like this.
There were a few more pieces to the first question here. The next piece was, does coffea-casa work under OKD?
Yeah, well, so yeah, the other point is that we're going to try. We already tested some pieces of coffea-casa on OKD. So for example, images, and they used in Fermilab, and but we need still to, so Bird, I don't know if Bird is connected. Bird will help us to test on OKD at Fermilab.
Yeah, the fundamentals work, but there's a lot of specifics that don't. So we'll have, we're working to get either not necessarily Casa, but basically a lot of the same framework of having Jupyter Hub and a Dask cluster and so on with OKD. So there'll be recipes for that.
Good. We'll let you solve it first before we borrow what you solve.
Oh, or we'll collaborate, Doug, with you and Chris. So.
Okay. We're happy to help.
Okay, thanks. And the last part of that question was, do special containers get submitted to HTCondor cluster?
Sorry, again, do the special containers?
Yeah, get submitted. Yeah, sorry, Doug, please.
Your figure showed a box which contains sort of the execution payload plus the Dask bit. Is that all run in a container? And if so, is it just an injection in a standard CMS container, or is it a special one?
We have, coffea-casa is using 2 different Docker images. One is for scheduler, and other one basically much more simplified Docker image, which allows us to start workers within our Condor workers. And we started. Which way we start? We use this. We called it coffea-casa cluster. Basically, it's like a Python module, which is extending the HT-Condor cluster integration. So here you can add, for example, you can edit your class add parameters for HT-Condor jobs and add, I don't know, image that you want to start in Docker universe and yeah, so this is how all magic is happening through this Dask job queue plugin module, Python module.
Okay, there's one more that we can take, and then we open up the discussion a bit more. And that last question was, how dynamic are the Dask workers in the most complex task? How long are the Condor jobs?
This is depends basically on your analysis that you write, and in the case we use the same queue that there is the settings for the queue is exactly the same as for all other CMS jobs. From the point of view, we noticed that, for example, having auto-scaling helps you a lot. Definitely this feature that I was showing before, when you can automatically scale up and down depending on the number of workers your analysis needs. So in this case, probably it doesn't take that much, it doesn't take that long usually. But it also depends on the available resources that we have. Yeah.
Okay. Thank you very much. I think with this then, we are going to move into what we have scheduled as discussion on the agenda, where we'll have a bit of time. And the idea behind this time slot now is that we have some time to discuss anything related to the workshop, anything related to the things you've seen so far. It doesn't have to be about the topics today. It can also be about the topics yesterday. And it can be now like your chance to discuss something where maybe you would like to hear a bit more. Maybe you have something where you don't quite see how your use cases would fit into the systems that we've been describing today here. So we would be very happy if you had some comments, some questions, so that we can discuss really the topics now that might be of interest to you. The way to do this is you're still welcome to use Slido, but to have this a bit more of an open discussion with a bit of back and forth, I think we can also take some comments, take some questions on Zoom. So please feel free to also raise your hand on Zoom, and then maybe we can talk a bit more about the contents of this workshop today and make it useful to you specifically and to your interests specifically. With that, if you do have any questions, I will give you a few seconds to get this started. Raise your hand on Zoom, write your question on Slido, and then we'll drop into a discussion. And in particular, if you don't have anything concrete that you can think of right now, one thing that's interesting to us working on this pipeline, working on all the different tools here, to know is what is missing in order for you to be able to use what we've been showing you for your specific use cases. So if you have any feedback in that regard with the user experience, with like critical pieces that are missing, those would also be extremely interesting to us and would be something that we would be glad to hear about from you now. Yes, I see one hand raised. Daniel, please.
Yeah, hello. Thanks a lot for this workshop. It was quite interesting yesterday and super interesting today as well to hear about all these tools and really nice features you guys working on to provide us nice and flexible way to deal with enormous amount of data we are waiting for in a couple of years after now. Maybe, yeah, I can maybe kind of like make a small question. So I'm working right now on a really huge analysis which requires actually working with it's WDKs to leptons. So almost any event which has at least one lepton is recorded and should process through our data analysis. And what I found is that working right now for me is we are creating kind of like software packages based on root, and user writes down script in a kind of like user specific way how they want to do analysis, but they run it twice. So first time they just do kind of like lazy thing, just collecting queries for histograms. Then we process it right now with a root data frame, because yeah, I will talk about it maybe a bit later. And then again, it's reprocess data again in the software to place histograms in the place it should be, and yeah, get the results. I might thinking about implementing Server 6 maybe, or even like whole infrastructure you provided right now as an adapter to this tool, since people are not really happy to rewrite their analysis. They're really happy just to take it. But we have really nice entry point right now where we can put this adapter for Server 6 or other things. But yeah, I was thinking about it even yesterday when there was discussions about it, and a just general question: how easy is it if user has a, let's say, object pickable or whatever, where he has a list of histograms with predefined cuts, with predefined files they want to read from trees, to convert it to your paradigm of data analysis? Yeah, so not convert, but implement it with your paradigm.
So I think, I mean, some of this is you can reuse existing code. I mean, the last notebook we showed yesterday does essentially that. It reads some data, it runs a processor, it applies some cuts, it produces histograms. And people are using this, I think, especially in CMS at scale. I'm sure some of the people here are connected. So anyone who has experience with this at a large scale, please also feel free to speak up to provide some more details. I don't think it's a huge change that is needed in order to switch over. For sure, there's like some code changes that if you're now working with root, that like things would look slightly different. I don't think it's a gigantic change. And I think it would be quite interesting to try this out, even on a subset of your samples, right? If you can even try it out with some amount of files just to get a feeling for how the workflow is like, and for maybe how also the performance compares, you might be benefiting a lot, for example, from like the caching that you can get for free. So I think this would be an interesting thing to try out. Ben, I see you are unmuted,
Yes.
so you might
Yes.
also have a comment.
So forgive me, because my background is software, not the physics. So I know about our data frame, but not really the specifics. Does it have kind of its own query language? And so that's what you're trying to see, that you could extract the way that you're specifying your queries in our data frame and somehow apply it to Service X. Is that a fair statement?
Yeah, maybe even like replacement of our data frame with uproot and just go directly to Service X is also fine for us. But this is just current implementation for us, because we also was struggling with scaling, and we're trying to do with a PyVF with the Spark. Was not really successful, but yeah, something at least.
Right. So one thing, Kyung-Yeon showed yesterday how he was able to take the tcut language and translate it into FuncADL that can drive Service X. And so I don't know whether our data frame, if we could somehow take your R data frame specification and automatically translate them into something that Service X could use, and then have that do all the cuts and slimming, and then at least give you a smaller file that is readable by Coffee that you could then carry on. So,
actually, I'm gonna show in maybe in Atlas specific session. I'm gonna show some example workflows with Service X. Maybe I believe one of those could be very relevant for your use case, I guess.
So I think people here would be very interested in trying to assist and like at least looking at how you're using it currently, and at least thinking about, okay, could we automatically come up with a way to translate that into this environment? So I think in theory, yes. In practice, I think we don't know.
Yeah, thanks. Would be interesting to have a look. Yeah.
Nick also posted a link in a chat. There was an IRIS-HEP fellow project and the presentation like from that quite recently of adding our data frame as a data source in Service X. So this might also be something that's quite interesting to take a look at. I don't know, Nick, whether you have any additional like comments on that.
Yeah, I can't add too much. I've forgotten most of this presentation in a few days since, but yeah, you can have a look. So they were making Service X as a backend source to provide the data to an R data frame computation graph and such. So lots of parallel and cooperative work going on.
Thanks. Yeah, this is certainly a very, very good reference. I see something that came up on Slido. Would there be a speed up or improved memory usage with the use of uproot coffee compared to our data frame? What's the difference between both methods? I'm guessing the answer to this might very much be it depends, but we probably do have some people here who have some more expertise who could comment on the technical differences between the approaches. I don't know whether Jim or anyone else might be able to comment here on this a bit more.
Yeah, I have to apologize. Difference between what and what?
Between our data frame, using our data frame and using uproot and coffee in terms of speed up or memory usage improvements.
Well, that's very broad. It's going to depend a lot on what you're doing. I mean, we all know here that generally what our data frame is, that it organizes a data pipeline between nuggets of C++ code. So really everything that you do in our data frame, the pieces are compiled. The I/O is the same as root I/O. So if you're I/O dominated, that doesn't really matter. We can't really comment on the exact, we can't talk about the performance without talking about a specific application. And some things, one will be faster and other things, another will be faster.
Okay, thanks. I think this is also like, it means at the same time, it would be interesting to just give it a try for the specific setups to see how in that specific use case things work out.
Yeah.
If also, I could.
Oh, okay. Go ahead.
I was just going to make kind of a tangential comment because I have experience with my analysis, which is going through unblinding right now, which was written in our data frame starting about 2 years ago. One of the things that you can run into is that suppose you have a model that's similar to what the analysis facilities are pushing towards, where you're not running from very extremely slim n tuples with lots of events cut out. You can end up with doing a lot of computations in our data frame. And then once you scale out to like 100 systematic variations and such, it can be with our data frame as it currently exists, not as it will exist very soon, you can get these a lot of time being sucked up by jitting these huge computation graphs and a lot of memory, which has been a kind of a bottleneck for my analysis of late. Once everything got scaled up, this is something that's going to be ameliorated with some of these functions. It's specifically the vary function, which is going to make things much nicer for our data frame in the future. But this is one thing that people should be cognizant about if they're not familiar yet.
Mm-hmm.
Yeah, thanks a lot for like adding this perspective. I think it's very useful to hear from people who have experience with the tools at scale. Sorry, Jim, were you going to say something else about this?
Yep, something orthogonal. These are all important points. The very, I heard about this vary node, which will do systematic variations without reloading the data, which is exactly what you want to do. So this is, using it what it really is for. The next loop, which is usually easiest to do, where for each systematic variation you reload the I/O, which is the worst thing, but that's usually the easiest. They're setting this up so that you can do it the right way easily. The thing I was going to add was that we are planning integration between awkward array and our data frame, so that awkward arrays can be a source or a sink to our data frame workflows. That doesn't help you in the present, but just to know that that this is something we're planning on in the nearest future. Actually, it's been on my to-do list for quite a while. But we're trying to make it so that you can use all of these things all together. You might end up reading something with uproot, turning into awkward arrays, running them through our data frame. Although, why couldn't you have just read the root files directly with our data frame? I don't know, but maybe some combination you'll find is a better sweet spot.
Yeah, I think this will be quite interesting also for people who want to just like sort of dip their toes into a different ecosystem and using like a piece of it instead of having to commit now to like trying out a lot of different things at once. Yeah.
Right.
Yeah, that's quite nice.
Yeah.
Okay, thanks a lot. Any other comments or like follow-up people have related to this topic? I think it's a topic that's quite relevant for people, of course. I mean, everyone wants their analyses to be easy to set up and like quick to run, and not have to like change lots of code to like keep things going. So I mean, we understand that there's some initial investment that's needed, particularly now if you are interested in potentially trying out a new system. But we would really be happy and also to help people try out these methods and like these workflows that we've been showing, just so that we can also learn what kind of bottlenecks might there be, what kind of user experience issues people may run into, and what other unexpected things that we maybe haven't seen might come up. And I think that's the way to improve the approaches and to learn more about how we can do things more optimally. I don't currently see any other question or comment. Yes, Oksana, please.
Yeah, I just wanted to add also a couple of ideas. So I think it's important to mention that what we are trying to do here is basically to build the full ecosystem together. So it is not only about, I don't know, coffee, or it's about delivering this unique user experience. Basically, I'm not saying that maybe coffea-casa will be a solution, or this is how we will planning to deliver all this ecosystem. But what it allows is easily to set up your environment and start to prototype and start to see what else we are missing. Because what we are really looking forward now, for example, with this analysis grand challenge exercise, is to understand what actually should be looking like the future analysis for us, like, I don't know, for physicists in 2 years, and how to cope with all this amount of data. And actually also I see that Root is also moving to the similar direction. They have also distributed their data frame, which is using Dask, which is yeah, by the way, for Danilo, maybe they're going to release a Dask version, so you don't need to use any more Spark, but maybe try on Dask as well.
Good to hear, thanks.
And as well, but we're going, I mean, we are kind of collaborating, we are not competing. So we just would like to understand what is the issues of for you to try these tools, or maybe some new features, or if you have any like ideas how we can make your life better, please write me or Alex, and we will try to help you.
I think the other thing to add at this point of the workshop is also that while we're about to be going into like 2 parallel tracks for Atlas and CMS, we did have quite a few people who were registered and indicated that they're in neither Atlas nor CMS. So there is some interest from outside these 2 experiments, and we would be very happy to organize any sort of follow-up event that might help understand a bit better what are the needs in your other experiments and how can we address them. So please do get in contact. We will have more workshops. We are happy to add additional kind of parallel tracks to discuss experiment-specific issues that you may run into. So this is something where not only in this workshop format, also maybe in like some dedicated meetings, it would be great to get in touch and to follow up a bit more and understand the use cases that you in particular might see. I do not see any other question, and we are, according to schedule, right now at time to go into break. So this is what we'll be doing. Before we do that, though, thank you very much to all the speakers, both yesterday and tomorrow, for preparing all the material, for giving the talks. Thank you to the audience for asking your questions, for participating in the discussions, for connecting, to following along, for checking out the examples. We will reconvene after the break in the Atlas and CMS sessions. Check out the experiment-specific agendas that are linked from the main agenda. And if you do have any follow-up items, don't hesitate to contact Oksana and me. We'll be happy to try to get you in contact with the relevant people if you have any questions about any kind of specifics, anything related to what you've seen today in this workshop. So we'll see some of you again after the break in half an hour in the experiment-specific workshops. To everyone else, thanks a lot for giving us your time, and we hope to see you again in the future in one of the next events of this type. Have a nice day. Bye-bye.
Yep,
Bye.
bye. See y'all in 30 minutes if you're on CMS.